The objective of this lesson is to be able to apply previous understanding of fraction division to accurately solve abstract fraction division problems. This lesson will allow students to practice choosing the strategy they feel is appropriate for each problem. The two interpretations of division are the measurement interpretation and the partitive interpretation. With the measurement interpretation, the common denominator strategy is very effective, while the invert and multiply strategy is often used for the partitive interpretation. The question that is answered with the measurement interpretation is, how many of this are in that, or how many divisors are in the dividend? The question that is answered with the measurement interpretation is, if this is enough for that, how much is enough for one whole? Or, if the dividend is enough for the divisor, how much is enough for one? The strategies that are used in the measurement interpretation are, when denominators are common, divide across numerators. Mixed numbers can be represented in parts and added back together. The size of each group is known, seek the number of groups. The strategies that are used in the partitive interpretation are divide then multiply, divide by the numerator of the divisor, the number of groups is known, seek the size of one group. The divisor is really the quotient in an area model. Dividing the numerator of the divisor, then multiplying by the denominator is the same as inverting the divisor and multiplying straight across. For example, 2/3 divided by 4/5. Divide by the numerator of the divisor. 2/3 divided by 4 ones is the same as 2/3 times 1/4. So 2 times 1 divided by 3 times 4 equals 2/12. Then multiply for the denominator of the divisor. 2/12 times 5 equals 10/12. This leads to the invert and multiply strategy. Invert the divisor, then multiply. So our 2/3 divided by 4/5 is the same as 2/3 times 5/4, which is 10/12. Let's now look at area models. This model represents a multiplication and division problem. C is the dividend, A is the divisor, and B is the quotient, showing that C divided into A groups equals B in each group. Or it could also be C divided with B in each group, which equals A groups. And for multiplication, A and B are the factors and C is the product. This is showing A groups of B equals C. A fence encloses a rectangular area of 1 3/5 of a square mile. One side of the property is 4/10 of a mile. In miles, what is the length of the second dimension of the rectangle? What multiplication equation could be used to check the answer above? Does it matter which strategy you use in this case? No, in this problem, either position is correct. Because of the commutative property, either way will give you the same answer. However, the top example is most commonly used, so let's try it. 1 3/5 divided by 4/10 equals B. 8/5 divided by 4/10. At this point, you would use the common denominator approach and change 8/5 to 16/10. So 16/10 divided by 4/10. Remember, when the denominators are the same, you only need to divide the numerators because the denominator divided by itself would just equal 1. So 16 divided by 4 equals B, and 4 equals B. The second dimension of the rectangle is 4. Let's check by multiplication. 4/10 times B equals 16/10. Replace B with our answer, 4. 4/10 times 4 equals 16/10, which can be written as a mixed number, 1 6/10. An equivalent fraction would be 1 3/5, which is the total area C in square miles. We got it correct. Let's take another problem. 4 1/6 divided by 5/3 equals B. One strategy is to use a drawing to solve the problem. First, draw a bar representing 4 1/6. There are 4 holes, and the last hole was partitioned into 6. The extra 5/6 are crossed out. Now draw a bar representing 5/3. Because the denominator is 3, partition each hole into 3 equal parts, or thirds. We want to find out how many 5/3 are in 4 1/6. So group the thirds into groups of 5. You can see from the drawing that there are 2 whole groups of 5/3 and some left over. Partition the last parts into 6. There are 10/6. but 5 of them are crossed out. So there are 1/2 of the sixth in the last group. So our answer is there are 2½ groups of 5/3 in 4 1/6. 4 1/6 divided by 5/3 equals 2 1/2. Another strategy a student could choose is the common denominator strategy. First, change the mixed number 4 1/6 to the equivalent fraction 25/6. 25/6 divided by 5/3 equals b. Now change 5/3 to 10/6, so there is a common denominator. 25/6 divided by 10/6 equals b. Now divide the numerators. 25/10 equals b. Next, change the fraction into a mixed number so it will compare to the mixed number 2 1/2 that we got earlier. 2 5/10 equals b. So the answer is 2 5/10, which is equivalent to 2 1/2. We can check by multiplying. 5/2 times 5/3 equals 25/6, which is equivalent to 4 1/6. We got it correct. Another strategy would be the invert and multiply strategy. 25/6 divided by 5/3 equals b. Invert the divisor 5/3 to 3/5 and multiply. So 25/6 times 3/5 equals b. 25 times 3 equals 75, and 6 times 5 equals 30. So we have 75/30 equal b. The greatest common denominator of 75 and 30 is 15, so we'll divide by 15/15, which is 1, so it doesn't change the value. 75 divided by 15 equals 5, and 30 divided by 15 equals 2, so 75/30 becomes 5/2. 5/2 equals b. 5/2 can be changed into a mixed number, 2 1/2. We just used 3 different strategies to solve the same problem, and they all worked. Have your child choose the strategy that works best for him or her and have them explain it to you. It's very important that your child knows why their strategy works rather than simply remembering steps. The objective for this lesson was to apply previous understanding of fraction division to accurately solve abstract fraction division problems. We met this objective by solving word problems with different strategies, determining the strategy that best fits the problem.